Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle called Fog Hammer Time by Electron. And here are the rules. Standard Sudoku rules apply, which means place the digits 1 through 9 in every row, every column, and every 3x3 box. And I say 3x3 box because there are extra cells here. I don't know what they're for. We'll see what they're for. Product bands. Multiplying the digits on two circles of the same color equals the sum of the digits on the line connecting them. Multiplying the digits on two circles of the same color equal the sum of the digits on the line connecting them. So it looks like this is the start of a product band. And say it went like something like that or something, right? And this was another circle. So if you multiply the digits together of these two, it equals the sum of the digits on the line connecting them. I don't think the ones on the corners are on the line, quote unquote. So basically, these two cells, if this was the line, these two cells, so those are the digits in the two circles, equal the sum of the digits on the line connecting them. So this would equal to the sum. So the product of these two would be equal to the sum of these four. Each product band is associated with a unique color and does not split. Okay, so it cannot go off into some weird fork. So you can't have something like that, right? That doesn't work. And it's unique. Each product band is associated with a unique color that does not split, right? It does not split too. It's a unique color. Digits on the endpoint of a product band index either their row, column, or box. Ah, okay. So digits on the endpoint of a product band index either their row, column, or box. So for example, say this was essentially the endpoint of a product band index. That would mean that this would be either indexes their row, which would be 5, right? 1, 2, 3, 4, 5. So it could be 5. It could be 6 because it's a column. 1, 2, 3, 4, 5, 6. Or it could be 5 again because the box is 5. And the box numbering is, this box is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9. So that's for any endpoint of a product band. They must index their row, their column, or their box. Okay. Interesting rule. Little killers. Digits along the indicated diagonal add up to a number provided and may repeat if allowed by other rules. So, for example, say there was a little killer. Say there was a little killer pointing like this way. So say it was like, I don't know, 15. Then that would mean these four digits would have to add up to 15, and there could potentially be repeats along that diagonal. So that's all that little killer is. Crop key dots. Digits separated by a black dot are in a 1-2 ratio. Not all black dots are necessarily given. So assume that, like, say there was a black dot here. Say there was a black dot here, right? If that's the case, then these two digits would have to be essentially in a 1-2 ratio. So one of them had to be divided by the other, would equal 2, essentially. And that's crop key dots. Fog. The grid is partially covered with fog. Correctly placed digits will clear the fog around that cell. So, for example, if you correctly place a digit here, all 9 cells around it, including itself, would be cleared. And no guessing is required, which means you can logic through the entire puzzle without guessing. And those are the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so because we know this is the end of it's the endpoint of a product band, that means the digit must index either the row, the column, or the box. Then the row and the column and the box are all 1, so this has to be 1. Okay, so there's no little killer clues here. This goes here. So this is 1 times itself then. What else do we have? Crop key, which we don't see. Lure killer, which we don't see. So this is at most 3 away. It has to continue 2, but it needs another one. I guess it could go back on itself, right? Okay. There are no Kropke dots. There are no little killer. So we know this cannot be 8 and it cannot be 9, because if to be 8, it would have to add up with... So it could be 2, 3, 4, 5, 6, or 7. It cannot be 8 or 9, because it needs to add up to 1 times another digit. And that would be at most 9. So it could be 2 and 7, then it gets added up to 9. It could get a third, it could be 2, 3, 4, and then add up to 9. Digits on the endpoint of the product band index either their row, column. Oh. It could be 2, 3, 1. Right. Where is the endpoint of this product band? It has to index on the endpoint. The row, the column, or the box. So that means this, if this is 2 and 3, this is at least 5. So the index has to be at least 5. And again, this line can be at most, I guess it could be... it could be 4 in length. But if it's 4 in length, I don't think that works, right? Say it's 2, 3 plus, I guess it could be 1 and 1. So we know this is at least 2, 3, right? So this is 2, 3. And say we had 1, 1, right? Then you would have an endpoint. But the problem is that the furthest this can go is here, right? Which is 6. And if you have 2, 3 plus 1, 1, that's 7. So it can never be of size 4 and still fit the endpoint rule. So this one specifically cannot be 2, 3, 1, 1, because then it ends. Even if we try 2, 3, 1, 1, 1, it can't go all the way across here, right? Because then that'd be 1, 2, 3. And then you would have 2 plus 3, which is 5, plus 1 plus 2 plus 3, which is 6, which would make 11. and you can't have a 1 times a digit equal 11. So that rules out anything that is 5. I think actually that rules out anything that's 4 or more, right? So if you have 4 or more, you could only have 2 plus 3, 5, 1, 1, 2, right? And that would be 9. But the problem is that this wherever this endpoint is would not correctly index um, the row, the column, or the box. So anything that's a foot length 4 is out. Now let's try length 3. So if this is 2, 3, you can go either 1 here, 1 here, 1 here. So that's 6 at minimum. But the problem is to continue on, the endpoint would be essentially 5 at most. So you can't have an endpoint of size. Sorry, you can't have a line here that's of 3 distance, because that still doesn't work because the 5 is too small, right? You have column 5, row 5 at most, and box 5 at most. Therefore, 3 is out. Therefore, this has to be a size 2. And the only one that works is, if say this continued, 2 and 3, this has to be the 5, because this is box 5. It's still row 4 and column 4, but it is the actual box 5. So this has to be 2 and 3, and this has to be the 5. This is a blue, and this is an endpoint, right? So this is either row 4, it's column 3, or box 4. So this is 3 or 4. This is row 3, column 4, and box 2. So this is 2, 3, or 4. Oh, interesting. And we do see the little hint of a blue here. So this is at most 16. Okay, so let's see where it can be. We know it's here, we know it's here, we know it's here, right? We do not see a line here, so it cannot cross across that way. So what's the minimum here, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a lot of digits. Is that really the minimum? I mean, technically, it could be this one, assuming we don't see, but I think we would see it here. That's the thing. So this would be 1, 2, 3, or it could be 1, 2, yeah, 1, 2, 3. Let's try to draw it. I think that's the minimum, right? So this is 1, 2. Let's just do it by row. So that's could be 1, 1, 2, 3, 1, 2. So this is 1 plus 6, that's 7. 1, 2, that's 10. 1, that's 11. And this has to be 1, 2, 3, that's 16? Maybe not that way specifically. Maybe it has to be like that. So this could be 1, 1, 2, 3. There's a lot of digits, basically. So I don't think it could ever be 12. There, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's no way it can be 12. Right, so 1 plus 1, 2, 3. Actually, it would probably make sense to not go that way. So remove that, remove this, and say it went like that, right? So this is 1 and 2, this is 1 and 2. So 1 and 2, so that equals 3. 1 and 2, that equals 3. 1 and 2, that equals 3. So that's 3 times 3, which was 9. 1, which is 10. 1, which is 11. And 1, 2, which is 14. So it's 14 minimum to get this. So this has to be 4 and 4 then, right? There cannot be a 3 and 4 because that would equal 12. So this has to be 4 and 4. So this is 4 and this is 4, right? We have a decent amount of degrees of freedom. What would those be? You have 14, right? So you have 2 degrees of freedom. But we don't know, yeah, so this is 1, 2, so the 2 degrees of freedom are from 2, essentially, which would mean it could be 1 through 4 along this line. But we don't, okay, so we know these two are part of the line. So this is 1, 2, or 3. We know these two are part of the line, so this is 1, 2, or 3. If we lose the degree of freedom, so say this was a 3. Sorry, say this was a 2. If this was a 2, that would mean this is 1, 3, and this is 1, 3, and we lose that degree of freedom. But that's possible, right? We have 2 degrees of freedom. So this still could be 1, 2, 3. We know the 1 is along here. We know the 1 is along here. So we have 4, 5, 6, 7, 8, 9 in the rest of column 2 and row 2. And we can remove 4 and 5 in the various spots. And this is 4 through 9. That can't be 4. This is 5 through 9. So this is 16. We have 1 and 5. We still haven't seen a little killer rule clue or a Kropke dot rule. So we don't know where this goes to, right? We do know there's 2 here, right? And so this could also be 1 through 4. We just don't know where the line goes after. So we know this is 1, so 1 has to be one of these 3. We know this is 1, so 1 has to be one of these 3. Excuse me. 1 going up to 2 and 2 going up to 3 is possible. So this doesn't have to have a 1 here. Remember, this is the minimum, right? We don't know that the line is actually on this trajectory. Huh. Okay. Okay. The problem is, yeah, I'm not really sure where anything else is. Right? This is no guarantee. Maybe. So what if it isn't this shape? That's actually part of the question, right? Say it entered here, right? We know this is at least 3. We know this is at least 3. We know this is at least 3. That's 9, right? So it could be 1, 2, 1, 2. Oh, that's interesting, actually. Right. I think it has to be 15 then. I think this is the lowest possibility here. But the problem is, then this would have to be 1 or 2. 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 So that's 15, which gives us only 1 degree of freedom. So then this would have to be a 3. And this would be 1, 2, if that's the case. Is there any case where we can come up with that it does not have that? If you go along here, that adds another constraint. So that's not possible. So even if you do something like that, I don't think that's possible, right? You add another digit, that's not possible. So if you add along here, this would make this 1, 2, and 3, which adds a different another constraint, right? Instead of having a 1, 2 somewhere, it'd be 3 instead. Right, so that would be 1, 1, 2, 3, 1, 2, 1, 2. Yeah, same with if it goes there, right? So if it goes here, this adds this makes us lose another constraint. So I do think this is forced to be a 3 then, and this has to be 1, 2, 1, 2. Yeah, because the minimum we found is 15, so that means we have only 1 degree of freedom now. So then, if this is a 2, that would take away 2 degrees of freedom, which we don't have. So this has to be a 3. So this is a 3, this is a 2. We do see a Kropke dot now. That's good. So this has to be 1 and 2. This has to be 1 and 2. Yeah, so this cannot be 4 anymore, right? So this does have to be a 1 here. So the 1 has to be here, the 1 has to be here. That means the 1 has to be along this line. Or sorry, this row. This is a Kropke dot. Only numbers can be in Kropke dots are 1, 2, 3, 4, 6, and 8. So 5, 7, and 9 are eliminated here. This has to be 3 or 4, but it can't be 4 because of that. So this has to be 3, and this is 6. So let's eliminate 6 from box 1 because of Sudoku. This diagonal adds up to 13. I don't know if we have any other information there. So this one cannot go here. It could go something like that. No, it can't go because that just adds another 4, right? Which we have already. So we know now this has to go this way, right? Because it's 1, 2, 1, 2. This would add a 3. I guess it still could be there. No, it can't be 3. If it goes here, this would add 5, which would up the constraint from 2 to 5, and we don't have enough. So it has to go this way. So that means this is 1, 2, or 3. It can't be 2. It cannot be 4 because of this number, and it could be 5, but that's you lose too many constraints, so that can't be 1. It can't be 5. So this has to be 1. It's either with 2 or 3. This is a 1, 2. We don't know about this. This could be a 3, so it could technically go here, and then back here, and then here. So that's fine. If this was a 3, this would have to be a 1 then. And then this would be 1, 2, 1, 2. This would be 1, 2, 1, 2. This would be, so that would be 1. This would be 2. So that seems reasonable. So the 2 has to be here. And the 2 has to be here. Okay, so let's just add this up. So this can't be 2. this is what? 4, 5, no 2, because the 2's here. No 4. This is 5, 6, 7, 8, and 9. No 6, obviously. Ah, this constraint. What is the maximum this could be? Okay, can't be 2 and 4. Can this ever be 5? If this is 5, this is 4, and this is 5, that already adds up to 14, so this cannot be 5. This has to be 1 or 3 also. So this can't be 1. This is 1 or 3. Or, sorry, it could be 1. This is 1 or 3. The 2 is here. This also cannot be 5. It can't be 4. This is 1, 2, or 3. We don't know where this could potentially go back here. So this one is not confirmed. But so this is 4 through 9, or 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9. And we have 2, 4, 5, 6, 7, 8, 9. No 6 because there's 6 in that row. Okay. So if this is 3, this is 1. That seems valid. If this is 1, this is 3. That seems valid too. 1, 2, 1, 2. It either has to be this one or this one, I think, right? So it goes either this way or this way. I think this is the same here. It goes either this way or this way. Actually, this one could actually go this way. Yeah, because this one we don't know where the 3 is. Here we have the extra information about the Kropke dots to make that a 3. So this cannot go this way. So this has to be 1, 3, 1, 3. We cannot add a random digit. I mean, technically, it could go something like this, then here. No, it can't be because that's 1, 3 specifically. It can't go this way either because that's also 1, 3, right? Okay, so this can never be 9. This can never be 9. Does this have to be 5? So this is at most at least 1 and 1. So that means 11 for the rest. So this is at most 6. Right, this could be 1 and 1 technically. I don't think it could actually. One of these needs to be 1. Right? I don't think it can actually be 1 and 1, but anyways. So say this is 4, this could be... This cannot be... This could be 4, 7. So say this was 1 and 1. That would mean there's 2 digits here. We lose 2 degrees of freedom. It would be 2 and 2. So it would be 1 plus 2 plus 3. 1 plus 2. 1 plus 2. So that's 6 plus 6, 12. This would have to be 2. 14, and then we have 2 digits which add up to. Yeah, so I don't think this can ever be 1 and 1. This could be 1 and 2, and that seems likely. So since this can never be 1 and 1, it's at least 1 and 2. That means this has to add up to 10 at most. So this cannot be 7, so this is a 5. So we can remove the 5s from all those spots. We do know it goes here. Well, we already knew that, though, from logic. So this cannot be 6. So this is 4 or 5. This could be 4, 3, and that's 1. That's possible. Or this could be 4, 1, 3, right? Or this could be 5, 1, 2. That all seems possible. Oh, we have 25 here. That was the additional information. This is 2. This is at least 6 and 7. This could be 3. Cannot be 4. Could be 5, 6, 7, 8, 9. So this is 2. This has to add up to 13 at least, so it's 15. So this is at most 10. Right? This is 2. This is at least 13. 6 and 7. So that's 15 total, which means this is at most 10. So this can never be 9, 8, 7. Oh, this has to be 3. Right? This is at most 10. It's 6 or 7 here, but 6 and 5 adds up to 11. So that would not work here. Therefore, this has to be a 3. So this can't be 3. This can no longer go this way. Because, yeah, well, also we see it. So it goes down here, so it can't be there. So then this is 5, 6, 7, 8, 9. No 6 here because of that 6. This is 6, 7, 8, 9. This is 5, 6, 7, 8, 9. Right? So 1 is here. 3 is also here. So this is 3. We have 1 degree of freedom now. So this has to be a 6, right? We have 2 and 3 and 6 at minimum. So this means this is 11. So this is 14 at most and 13 possibly. 14 requires a 6 and an 8, or it's 6 and 7. So this has to be the 6, which means neither of these are 6. Neither of these are 6. And this is 7 or 8. So 9 has to be here, which means this can't be 9, and this can't be 9. Because 9 is long, no, and 9 can't be here because of the little killer constraint. So either this is 6 and this is 8, or this is 7 and this is 7. Oh, interesting. Okay. This is 1 or 2. This is 1 or 2. Therefore, there has to be 3, 4, 6, 7, 8, 9 everywhere else on the column. 6, 7, 8, 9. Because we have a 1, 2, 1, 2 pair. This technically could be 2, so we don't know. So it could be 1, 2, 3 here, 1, 2, 3 here. So this is 3, 6, 9. Yeah. Okay, so that constraint's done, essentially. This constraint's kind of helped. Kind of. Oh, this can't be 6, this can't be 6. This has to be 6 here. Okay, and then we have a Kropke dot, which is a 1 to 2 ratio. The only one that fits is, whoops. is 4 and 8. So this is 5. This goes down here. So this line is no longer possible. So it probably goes here. This can't be 5 or 8. This can't be 4, 5, or 8. So it's a 7, 9, 7, 9 pair. This can't be 7. Therefore, this is... Yeah, the 7, 9, 7, 9 pair eliminates 7 and 9 in box 1. So this can't be 7 or 9. This becomes a 5, 8 pair, which means this is a 7, 9 pair. Which means this is 8, because the 7 and 9 are eliminated in box 2. This has to be a 4. So no 4 and 8 here. This is 2, 7, 9. So it's 5 and 5. So this has to be 1 and 2. So this is 1, this is 2. Which means this is a 3, and we've lost all constraints. Therefore, this is a 1 and 2. This has to be a 1 because of the constraints. This is 1 or 2, this is 1 or 2. Therefore, the 1 or 2's has to be here. This can no longer go this way because we've lost our constraints. So we know then this is 1 or 2 because of constraints. And it can't be 2, therefore this has to be the 1. This has to be 2 then. No 2 here. No 1 here. No 4 here. And this can't be 2. This is a red 1 here. No 2 here. So this is 1, 3. This is 1, 2. This is 1, 2. We know 1's here. We just don't know. Okay, so 1, and then 7, 8, 9, I think, is with it. 7, 8, 9. This is also 7, 8, 9. Okay, so this is 4, 8, 4, 8, 5, 5, 1. Okay, so this is 8 now. So this is adds up to 10. So this has to be a 6 to add up to 25 for the killer cage. So this can't be 6, this can't be 6, this can't be 6. This becomes 3, 5, 7, 8, 9. This can't be 1 or 2. So this can't be 6 because of this 6. No 1 or 2. So this is 3, 4, 5, 6, 7, 9 as possibilities. This red, we don't know where it goes. Let's see. This is 2, 4, 6, 7, 8, 9. Obviously no 2 here, no 2 here because of these 2's. This becomes 3, 7, 8, 9. So this is 3, 7, 8, 9. This is 3, 7, 8, 9. Therefore, this is a quad set, which only can contain 3, 7, 8, and 9. So where's the 4 and 6? They have to be here. So this is 4 and 6. So this cannot be 3 because we know the 3's here. So this is 7, 8, or 9. This can't be 3 or 1 or 2. So this is 4, 5, 6, 7, 8, 9. No 6 because of that 6. And the 3 has to be here. And no 6 here. Okay. Okay, so all the little killer clues are done. This product, the blue product band is done, the green product band is done, these Kropke dots are done, essentially. So it's really this red one? So this has to go here. Obviously, it's larger than 1. So we know the 1 is here. Okay. This does not seem like an easy puzzle. I would not classify this as easy. I would say this is at least average difficulty. A lot of thinking involved, certainly. Oh, wait, we know what that is. Okay, right. So this has to be either 5 because of the column, 8. It cannot be 8 because of that, because of the row, or 8. So this is 5. Yeah, that's a 5. Okay, so then we can remove that line because it has to index the row, the column, or the box, and it specifically indexes the column. So there's no 5 here, no 5 here, no 5 here. Interesting. Okay. So this is either, so we know it continues here. Um, hmm. So the red line ends either here. The red line has to end in one of these 5 boxes. Because of that, it can't be 1. Well, it couldn't be 1 either because that would be 5 and 1. And that would be 5. And there's no way that there's 4 digits or okay, 3 digits definitely on the line. And so it's a minimum of 6. Except that it's 1, 3, and 4, so it's a minimum of 8 really. It cannot be 5 and 2. So it can't be 5 and 1. It can't be 5 and 2 as the endpoints because the 2 has to be here. I guess technically it could be, but then if it's 5 and 2, then it's 5 in length, and that adds up to at least 15. So that's not possible. Um, can it be 5 and 3? Yeah, it could be 5 and 3, and the 3 being here, it's perfectly fine. Because this could add up to 15. And this is in column 3. Oh, that's one thing. Yeah, I forgot. The 2 doesn't index anything. Can it be 5 and 4? If this was 4, so we know the 4 is along here too. So it's 2, 4, 5, 6, 7, 8. Oh wait, it's 2, 4, and 6. Yeah. Where can the 2, 4, and 6 be in? Well, let's see, we have a 4 quad, which have 4 unique digits. So everything for 5, 7, 8, 9 is eliminated. Therefore, this is 2, 4, 6. Right. And so if the endpoint were any of these, this is row 7 and above. So it's row 7, 8, or 9. So none of those fit the index. So the rows don't fit. The column is 1, so the column index doesn't fit. And then the box is 7, so the box index doesn't fit. So this cannot be the endpoint. So the endpoint's either here or here, right? We don't know which. So it could be here or it could be here. We don't know. If it's here, it could be, okay, so say it was here. If it was here, it would have to be either 5 or 7. Actually, it can't be 5 because the endpoint must index something, right? It can't index 1. It can't index, this would be row, sorry, yes, row 9. So it could be 9 and 5, but there's no way this adds up to 45. It could be 7 and 5, but there's no way this could add up to 35 then either. So it would have to be 5 and 5, but the problem is there's no 5 index. So it can't be 5. So this cannot be the index. Therefore, this has to be the index. And again, it can't be 9. It can't be 7. So that's row 9, column, box 7. So none of those work. This has to be a 3. So this is not... Okay, so then we know that this is not possible. This has to be it. So we should see this as we put in the 3 here, because 3 and 5 is the only possibility. It cannot be 7, it cannot be 9. And those are the only indexes possible, 3, 7, 9 here. So this is 3. So this can't be 3, this can't be 3, this can't be 3. These 3 add up to 15. So if this is 4 and 6, this can't be... This would have to be 7 at least, but that doesn't work. So we're saying this isn't 1, right? If this is not 1, this would have to be 7, but it would have to be with 4 and 6, which does not work. So this has to be the 1. So we know that's 1. This can't be 1. Oops. This can't be... This cannot be 1. So we have a 7, 8, 9 set here. So there's no 7, 8... This is a 7, 8, 9 triplet, which means 7, 8, and 9 cannot be in anywhere else in in row 8. So 7, 8, and 9 are eliminated here. In addition, this 1 can't be possible, so the only possible place for 1 is here. So this is a 1. And we have 46, so this is 2, 3, 4, and 6 because the 7, 8, 9s all are here. So this cannot be 4 and 9. It has to be 6 and 8. There's no 5 possible. There's no 3. That doesn't even work. So the possibilities would be 1, 5, 9, but the 5 can't be there, or 1, 6, 8. So this has to be 6, and this is 8. To add up to 15. So no 6 because of these numbers now. So this is 8, which means this can't be 8 because we have a 7, 8, and 9 set here. This can't be 6, no 6, no 6 or 8 here. No 6 or 8 here. This can't be 6 anymore, so this is 4, this is 6, this can't be 8. So this is 8. This can't be 4. So the 4 is one of those two. This can't be 6, no 4, no 6. So then we need to add up this row. Yeah, I think this is a little bit on the harder side. This is not easy. It's not hard either, though. So, we just need to add this up now. So this could be 3, 4, 5, 6, 7, 8, 9. No 6 here, obviously, because of this. Let's add these up minimum. Okay, or actually maybe maximum. This looks actually like a maximum here. So 4, 9, 4, 9, 2, 9, 9, 1. Okay, so 4 and 9 is 13. 4 and 9 is 13, so that's 26. 2 is 28. We have 9 and 1, 38. And then, yeah, so there's only, I think, 1 degree of freedom down, right? So if this is 4, 9, 13, 4, 9, 13, 2, so it's 13 plus 13 plus 2, which is 28. This could be as a maximum 9, 1, so that's 38, and then 9, it's 47. We have 1 degree of freedom, so this has to be a 9. This has to be a 9. We have 1 degree of freedom on this, therefore that's a 9. This is a 9. This could be 1 or 2, so that forces this to be 7. That's a 9. That's a 7. This is 8. This has to be the 9 then. This is 5, 8. This has to be the 8. This has to be 7. This is 3 because this can't be 9. So this is 9. This is 7. This is a 2, so this has to be 2, 4 because it's a 1 to 2 ratio. And so therefore this is 6. This is 4. This is 2. This is 4. This is 6. This is 3. And this is all just because of eliminations from Sudoku. So that's 3. This cannot be 9. No 6, 7, no 7, no 7, no 7. This can't be 7 or 9. This can't be 3, 7, or 9. This can't be 7 or 9. This has to be 7. No 4, no 6, 7, no 3, 6, or 7, no 3 or 7. Okay, so now, again, this can't be... so we've lost the 9 here. So that's our degree of freedom. Therefore, this is 8. This is 9. This is 9. This is 2. This is 1. This is 2. This is 1. This is 4, 5, 2, 1. Yeah, and this is all now because it's just a regular Sudoku. 9. This has to be a 2 because the 9 can't be there. So this is 7, 9. This is 2. This is 8. 5, 6, 4, 3, 4, 8. So this is 5, and this is 7. And that's the solve. Yeah, not easy in my book. This would be average level difficulty. What requires a decent amount of thought, especially like trying to figure out the minimums and the maximums. And then also what these shapes could be. That was really the key. That was the hard part, was figuring out what the shapes could be. Plus the indexing, remembering that the rules of the indexing was important. It was very important, and I sometimes didn't really take that into account. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.